now that we've gotten through the section on annuities, it actually makes the idea of what we call the amortization formula quite a bit simpler. So the amortization formula is a formula for loans, which is typically people use that to mean what is a formula for calculating a necessary monthly payment to pay off a loan in time. So, like, say for example, you borrow $50,000 from the bank to go to school or to buy a yacht, or that doesn't make any sense, but whatever, you borrow $50,000 and there's a particular interest rate on it. Let's use a typical student loan interest rate of, say, about 7.2%. Well, technically, currently, students' loans are not generating interest due to the whole coronavirus economy deal, but we're assuming we're under more normal circumstances where interest is actually accruing. But anyways, let's say you borrow $50,000 at an interest rate of 7.2%. And basically, how typical loan repayment program or calculations are done is we want to figure out a number, like what payment should I make every single month in order to pay this off. And obviously, what we'll factor in is, well, how long will it take me to repay this? And they're almost always done monthly on a monthly basis, meaning so compounded monthly, um, little n is equal to 12. But the question is, what is R? What should our payment be? And notice it's very similar to that of an annuity, where an annuity is something where I'm paying every single month in order to generate a complete value. We could imagine the bank who is lending us money, say Sally Mae, um, as purchasing an annuity. We're like their annuity. The money they give us will be paid back to them over time after we have a job and become rich and successful, hypothetically. Um, so basically, all the annuity formulas can be used to figure out what would the payment need to be in order to properly pay this off. And since the bank is thought of as purchasing the annuity, the amount that we initially borrow, the principal value of our loan, $50,000, the uh, would be the initial value, the present value of the annuity A. So it's not going to be capital S, it's going to be capital A from the previous formula because it's a current purchase price. It's purchased all up front, and then we're trying to figure out what payments we'll need to pay it off. So instead of thinking of it as adding, it's more like we owe this and we're subtracting to pay it off. But it's the same exact thing. Instead of an additive geometric series, it's subtractive. But in the bank's mind, it's an additive series. Anyways, basically we could solve the necessary monthly payment amounts by using exactly the same formula to calculate the payment amount for an annuity with present value of A and ratio of parameters A of N and P. And also another thing, the term amortizing uh, is applied to specifically the splitting of a loan because as you are paying off your loan, part of what you're paying off is interest and part of what you're paying off is the actual original loan. You start off by paying off mostly interest because at the beginning is when the interest is the highest because your balance is the highest. And as it's paid off, interest gets smaller and smaller and smaller until you perfectly pay it all off. Um, but anyways, in the book, and this is kind of why I wanted to get into this because there's a ton of formulas in the book, and if you look at it without having studied the previous sections, this would be enough formulas to make your head spin. But really, all of these formulas are geared to solving specific parts of the formula, um, where number one is the amortization formula itself, which gives you the monthly payment amount. So R is the monthly payment amount, which is determined by this particular ratio, or again, in expanded form, full form is listed like that. So in your packet, I decided to put it in both forms in case you want the compressed or not. And unfortunately, Microsoft does not do the finance notation very well, so just use your imagination. Um, Also, in the amortization formulas, it's split up in terms of, well, how much net principal is left after the K payment. So say we've paid it off 12 times, and we want to know how much is left. This formula will give you how much is left over of the loan. This formula will tell you how much of your payment was interest and how much is principal. And then the very last one gives you the total interest paid. But let's get into some examples of actually using these.